Hello and good afternoon. This is Ritesh Jaspal and welcome to PW UPSC once again. So today, once again, I am connecting to all of you through this recorded lecture, right? But then it doesn't make any difference because the learning is going on, and I am sure that you are paying full attention to the coverage in class. And we are in the last class of IT and communication. Moreover, we'll finish it IT and communication, right? And then we'll start nuclear technology in today's class only. So what we are going to discuss today. So first of all, in the last class we had a discussion about big data. So that was about big data, and then after big data we had discussion about Web 1.0, Web 2.0, and Web 3.0. So these are the three topics that we had already discussed. 1 and 2 we have discussed it, but Web 3.0 is something that we have to talk about. We have not yet completed it, right? So that we are going to discuss today. So in today's topic, we will discuss Web 3.0, that is the one topic, and we are going to start a new topic that is called nuclear technology, right? Nuclear technology. Got it? So let's start with that. Like in the last class when I was talking about Web 3.0, then I told you that this is something called decentralized web. So Web 3.0, this is called decentralized web. Problem with this web is what? The problem with this web is nothing, but the problem was with Web 2. Web 2 had a problem, and the problem was that in Web 2, emergence of third party was a big issue. So we had a problem with emergence of third party who were basically regulating the entire web. Virtually they become owner of the web. They were controlling the entire internet traffic in a majority way. And the second thing, that our data, the users' data, what at their disposal. Because in Web 2.0, one thing was there. Then in Web 2.0, all the data that we put in, that is stored on a central server, cloud server. So if we compare it with 2.0, let's say if I write here, 2.0, the problem was what? So Web 2.0, and the problem was very simple. The problem number one was third party, right? So everywhere the third party is there, and they're getting their own cut, they're getting their own benefit. The second was big company controlling, or you can like internet control by big company, right? And the third important thing, that user data at cloud server, or you can like center server, cloud server or center server. So this was the problem with Web 2.0. We know that. And then there was emergence of Web 3.0, and Web 3.0 is all about that now this all problem will be solved. Like I told you, this term was given by Gavin Wood in 2014, but it became popular in 2021, and Web 2.0 is now being slowly replaced by Web 3. And this is decentralized web, where there is no third party. It will promote peer-to-peer connection. Like I can connect to you directly without any application of the third party, right? So it will be a kind of open web, which will promote peer-to-peer connection, right? So what would be the characteristic of it? Let's say the characteristic of it would be, first thing, it is decentralized web, that is there. Second, it will promote peer-to-peer connectivity without third party. So no third party will be required in that. Just people-to-people connectivity without any third party. Second thing that we can say, like user will be owner of, or user will have control over his or her data. So our data in our control, and that will diminish the role of the big companies in it, because they are making money because they are putting all the data at the central server and they're using the way they want, right? And third one, that user data will be stored at user end. User end का मतलब that my data will be stored in my computer, in my laptop, in my mobile phone, and that is the concept of edge computing. Edge computing. So there is a difference between cloud computing and edge computing. So cloud computing is when the user data is stored at a central server, that is called cloud computing, and the cloud is owned by big companies like Google, Amazon, Microsoft, Facebook, Dropbox. So these are the big company which owns the entire cloud system, and once your data is there on the cloud, then obviously they can make use of it the way they want, and that is how they are using it. But if we have our data, at our end, then the control over data will be with us. So with single click, we can just remove our data from the entire internet, and nobody on the internet, no company on the internet will be able to access us, right? So it will give you better security and privacy, right? So that is edge computing. The data of user is there at their own computer. So my data is at my computer. So what I'll do, I can just simply remove the data from the internet. I can just switch on or switch off the data, kind of that, and that will give us, it will provide us what? Better security and privacy. Better security and privacy than what we have done in Web 2.0, right? But the biggest challenge is how this peer-to-peer connectivity will work. How this peer-to-peer connectivity will work without any third party. So the entire Web 3.0 will be based on one technology that is called blockchain technology. What we call it? Blockchain technology. In blockchain technology, all the data will be connected and it will be written in a block format, right? So what is blockchain? I'll tell you. So again, you can write one more point. Next point. You can write Web 3.0 is based on blockchain technology. Blockchain technology, based on blockchain technology, right? Right. So blockchain is a kind of open ledger. It's an open ledger. It's an open account where any transaction, any data change that can be recorded, and this blockchain will be available to every one of us. So let's say if I'm selling this marker to you, so when I'm selling it directly to you without any Amazon or third party, so with this marker, online data, one information will be added, and that information will be added like I have sold it to you, and this information which has been added to this marker can never be omitted. It will be always be there. So blockchain technology works in that way. Let's say if there is something X, if X is something, and that I'm selling this X from A to B, So A has sold it to B. So A has sold this X to B. So this information block will be added. It is added. Now B is selling to C. Is selling it to C. This information block will be added. Right? If C is selling it to D, if the transaction is occurring, then what will happen? This will also be added. And if D is selling it to E, then this will also be added. What will happen eventually? That all the data, all the transactions that is linked to X will be attached to X. You can never change it. Nobody can delete this A to B or B to C. So not only you get the entire previous record, but you also get authentication that how it has been sold and at what price it has been sold, and that will promote more transparency, and this transparency will bring the security, privacy, and everything. This information block is known as blockchain. This is called blockchain. And here the block is what? Block is a data block. So these are the data blocks which has been added. And this can be, this can be seen by anybody. Anybody can see this blockchain to find out that how X has been sold. What was the history of X? So let's say in the next time when E is trying to sell it to F, and F is basically trying to get all the information about the X, that what is X and how the X has came to E. So what will happen? The F will be able to track back all the record, all the data which is there in the block. That is called blockchain technology. Right? So you can write. So you already written Web 3.0 is based upon blockchain technology. Blockchain technology. It is an open ledger. Ledger means bahi khata. It is an open ledger on internet. Open ledger on internet, where every transaction, is digitally printed. Is digitally printed in the form of information block. And this cannot be changed or deleted. And it can be viewed by any user. Blockchain technology will eliminate role of third party. Like bank, social media, e-commerce site, etc. Right? E-commerce site, etc. So even this blockchain will not be needed for any financial transaction, because financial transaction will be done on the basis of cryptocurrency. Cryptocurrency is like X is a cryptocurrency, and in X cryptocurrency, what is there? Like A sold it to B, B given it to C, C given it to D. All data will be collected together. So you can track back that from where this money has come. Let's say if I give you 2,000 rupees to you or 500 rupees to you, then and you give this 500 to somebody else, then that person is not able to understand that from where this 500 rupees came. Right? So I have given 500 to you, and you are giving it to the next. The next person will never get to know that from where this 500 rupee came. But in blockchain technology, if I give one Bitcoin to you and you sell this Bitcoin to the next person will be able to track back all the transaction of that Bitcoin, and it will be written in open ledger. This ledger can be viewed by anybody. So you cannot deny that you have not taken it, because this every Bitcoin will have information that from where it started and at what point it is going. So what will happen? Then it will have something like that every single transaction is written, that cannot be omitted, and then there is no need of bank or third party to authenticate it, because we all will be authenticated. We all will be authenticated. So you can write one more point. Right. Web 3.0 and blockchain technology. Web 3.0 and blockchain technology will promote cryptocurrency and NFT, non-fungible token. Cryptocurrency and non-fungible token. You know the cryptocurrency one, right? NFT is what? NFT is a kind of digital art or something which is very unique in a digital world. So let's say if I click a photograph and this photograph is very unique, I can sell this photograph as NFT. It is a non-fungible token. That means there is no fixed value of it. It's like painting. Like if you buy MF painting, then there is no fixed price of it. So there is no fixed value of MF painting. MF painting can be sold in lakh rupees and next time in crore rupees, and it is unique because it is just one piece. Like Mona Lisa painting, it is unique and just one piece. Copies can be there, but the original authentic thing is just one. Similarly, in digital world, now we are having digital art, some specific data, and this digital art and data is just a single copy, and then it is being sold to somebody as NFT. Like I give you one example, Twitter, that has been renamed as X. So Twitter's first tweet is now NFT. And somebody in America bought this NFT in millions dollars, 16, 17 million. And he bought this first tweet of the Twitter. Now, first tweet of the Twitter, that is NFT. It is not coming to you. It is in digital space. But the ownership is with you because you have paid this money. And once this ownership is with you and you have paid this money, it means what? It means that everybody would know that, okay, you are the owner. So that is NFT. It's like putting a painting in your house. So now the person who have bought this first tweet of Twitter. Now this person is allowed to use and display this first tweet of Twitter everywhere. Like that person can use it like DP, that person can use it like anything else, right? So this digital right has been given to that person, and now this person can sell it to the next person. So he might have bought in a 16, 17 million, and if he get an offer to buy, sell it in 25 million, he will sell it. So NFT is a kind of digital art. It's like painting or anything like digital world, which has got very important value, but price is not fixed. And how will I understand this digital art belongs to it? Because that will also be sold like NFT. So if this NFT is with F, F is owner because in the blockchain the last name is F, and it will also tell that this NFT was where, kahan tha wo, kahan se aaya tha. So A got this, B to C, C to D, D to E, and E to F. These are all persons, correct? Again, you right? Next, you right? Web 3.0, Web 3.0 will be decentralized web. Will be decentralized web, where data and internet traffic, data and internet traffic will not be controlled by few internet companies. Rather, every user will have ownership and control on his or her own data. Right? So that is what I told you. Next, you can write. Data will be decentralized. Data will be decentralized, and it will not be stored on central server or cloud server. Rather, the data will be stored at user's device. Right? And this will be known as edge computing. So edge means at the edge it will be stored. This will be known as edge computing. So I'll give you one example like what edge it will be. Let's say these are the users. We are the users. So these are the users. And if you put all the data of the user at a central server, then this is cloud. So this is cloud computing. But if you keep all the data, if all the data is here, it is here, and all the data is being shared between this. So this is basically what? It is your edge computing. So data at central server, that is cloud computing. Data as at user's end, that is called edge computing, right? Edge computing. So that is all, right? So this is what the Web 3.0, but again it is in a formative space. Now the next topic is two things we'll talk about. One is Web 4.0. So this is basically called mobile web, and we know very less about it because this is not something that we understand properly, right? And this is also called or symbiotic web. Symbiotic means that man plus machine. But I'll tell you again that the whole idea of Web 4.0 is still in a delimited stage. We don't know. There is no clear idea about it. So this is what I can say, that for Web 4.0, I can tell you it is not very clear that what it would be. But then one thing came. Concept of Web 5.0 came, and there is some clarity about it. So first of all, you need to understand what is Web 5.0. Web 5.0, according to some people, it is basically Web 2.0 and plus Web 3.0. And 2 plus 3 is what? 5. So it's not like Web 5 is 2, 3, 4, 5. No, they are saying that Web 2 and plus Web 3 put together we can make Web 5. Right? Web 2 and 3 put together we can make Web 5. Right? So this is this concept was developed by Twitter's former CEO Jack Dorsey. So Jack Dorsey has given the concept of Web 5, right? So the concept by Jack Dorsey, right? So ex-CEO of Twitter, and this person was moved by the concept of decentralized web, right? And ownership of data and identity to individual. He's promoting this idea, and he's of opinion that okay, Web 2 should be there, social media and third party, that all should be there. But even if they exist as a third party and social media platform and e-commerce platform, the ownership of data and identity should be there with individual, right? So that is basically a kind of combination of Web 2 and 3, right? Right. So you understand it? So it will have benefit of Web 2, like all third parties will be there, and then decentralization of the data by Web 3. So it is not of opinion. Web 5 is not about that replacing something. Normally we understand Web 2 and then Web 2 will be replaced by Web 3. No. According to this gentleman, Web 5 will be the existent. It will be coming in existence, and Web 5 will be 2 plus 3. Web 2 plus Web 3. And Web 2 means that all the things of the internet will be there like the way it is. But then the data and identity, ownership will be there with the user. Got it? So this is still in essence stage. ऐसा कुछ नहीं कि इसके बारे में बहुत लंबी बातें करेंगे. There is nothing much about it. You just need it to the concept. Yes, you might have come across some terms like blockchain technology and NFT, and I'm sure that you must be knowing it because these are the very common things which are going on the internet. So try to read a little more about it, and you will get the idea. But I have taken the entire thing in a bigger picture. So that is the last topic that we have left in the last class. Now we can move on to the next topic. Right? I know that you are feeling a little bit alienated, not connected to the topic because we are not connecting on a regular way like we used to connect. And believe me, I feel the same thing. Sometimes it feels like being mechanical, like I'm teaching the camera, but I keep you and your entire class in the mind when I teach, and I try to give the same output. Right? Anyway, so it's a matter of 1-2 days. Maybe from the next week we will be able to continue our live classes. And now we'll move on to the next topic. And the next topic today that we are going to discuss is nuclear technology. Right? So should we go with that? So next topic is nuclear technology. Nuclear technology. So this is an important aspect. And first of all, I'll try to explain some basic concept of the nuclear technology. And for that, you need to understand that in chemistry, we have 2 types of reaction. One is called chemical reaction. Chemical reaction. And then another is called nuclear reaction. So chemical reaction and nuclear reaction. Nuclear reaction, right? So chemical reaction and nuclear reaction that we are going to talk about. I know that many of you are from science background and you know it very well, but my concern is with the arts and commerce background student who don't know, and maybe they have skipped it because it's been long that you have studied it. So I write a chemical reaction in front of you. Any chemical reaction I can write. Let's say I'm writing a chemical reaction that is NaOH plus HCl that gives NaCl plus H2O. It's a chemical reaction, right? At the same time, I'll write a nuclear reaction as well. A nuclear reaction I'm writing H31 plus H21, that is tritium and deuterium, that is the hydrogen isotopes. And then if we combine it together, then it will give you helium 4 2. 1 neutron will come up, and then lots of energy will be there. E for energy, right? You got it. So can you differentiate now that how this nuclear reaction and chemical reaction are different? What is the main difference between these both? Difference between nuclear reaction and chemical reaction that we are trying to understand. So it's a very easy way, right? Many people may be understanding not anything, but I'll tell you very common thing. The first thing that you understand in a chemical reaction, nuclear reaction, the first difference is that in a chemical reaction, new element will never form. There is no new element formation take place. Because here is sodium, oxygen, hydrogen, and chlorine. Here also you will get the same thing. But in nuclear reaction, you get that. We started with hydrogen, and we are having what? Helium. So helium is what? A new element formation took place. So forget everything. When there is one reaction, and you have to find out that whether it is a chemical reaction or nuclear reaction, just focus on one thing. If it is having a new element formation, then it is a nuclear reaction. And if it is not having any new element formation, the elements are same, but a new compound formation took place, then it is chemical reaction. So here what will happen? New compound will form. New compound will form. क्या बनेगा? नया compound. लेकिन यहाँ क्या बनेगा? New element will form. So this is very important to find out. New element will form. This helium is a new element. Helium was nowhere, but here you won't find anything new. These all are same, but only new compound form. Element remains same, right? Another thing that you can understand about chemical reaction, you might have heard the name of a scientist called Lavoisier. And Lavoisier has given a theory of law of conservation of mass. According to Lavoisier, he said that reactant and product will have same mass. Let's say if I'm taking 5 kg of sodium hydroxide NaCl, then I'll get 5 kg of NaCl and H2O combined. So if this is 5 kg, this will also be 5 kg. There will be no mass change. Mass will neither go up nor it will come down. So mass will remain conserved in chemical reaction. In chemical reaction, mass will remain conserved, right? So again, I'll tell you that if I take 5 kg reactant, so products will also be 5 kg. The NaCl and H2O together it will be 5 kg only. So in a chemical reaction, what will happen? The mass will remain same, and that's called law of conservation of mass. So mass remains conserved, mass will remain same. But here what will happen? Mass defect will be there. If you take 5 kg of hydrogen, you can never get 5 kg of helium and neutron put together. There will be certain loss of mass. So this loss of mass is USP of the nuclear reaction, right? So there will be loss of mass, and that is known as mass defect. What we call it? Mass defect. So this loss of mass, that will be known as mass defect. Certain degree of loss will be there, 100% it will be there. And this mass defect is also known as delta M. What we call it? Delta M. And this delta M is where the mass has gone. Mass has been lost. That means you take 5 kg of hydrogen together, then you get 4.99 kg of helium. So even 1 gram of the mass is gone. If the 1 gram mass has gone, then what happened to that mass? According to Einstein, this lost mass has converted into energy according to the formula E is equal to delta mc square. Right. So this formula you must have heard about, must have read somewhere. And E is equal to delta mc square means this mass which has been lost during the nuclear reaction converted into enormous amount of energy. And I'll tell you one thing, that C is speed of light and C is 3 into 10 to the power 8 meter per second. So you can imagine even a small amount of mass will convert into enormous amount of energy. Why? Because that will multiply with, according to this formula, this is going to multiply with 3 into 10 to the power 8 meter per second, a square of it. So it is 9 into 10 to the power 16. So even 1 gram of the mass has gone missing. So this missing mass is basically going to convert into what? It is going to convert into energy, and this will convert into energy with the formula of E is equal to delta mc square. And then C value will determine that how much energy will get. And C is 3 into 10 to the power 8 meter per second. And C square is what? 9 into 10 to the power 16 meter per second. So that is why nuclear reaction like atom bomb, hydrogen bomb, that can give enormous energy, lots energy. Energy can come out over here, but energy will come out over here, that will be less. It won't be too much. It will be just less, not too much. But energy there in nuclear reaction, that will be huge. वहाँ पे uncomparable energy मिलेगा, right? So this is one particular thing. Another thing that you should know about nuclear reaction and chemical reaction, that is if you understand the structure of atom, so neutron and proton. So neutron and proton, this is what? This is a nucleus where neutron and protons are there. And then this is what? Orbit, where electron is moving around. So another thing, that this is electron, and electrons are responsible for two things. Electrons are responsible for two things. First, chemical reaction. Chemical reaction, right? Chemical reaction. And electron is responsible for chemical property. Chemical properties of the element. So remember, in chemical reaction, which one is involved? Electrons are involved. And we are not talking about chemical thing. But if we talk about this one, this proton and neutron, together they are known as nucleons. What we call it? Nucleons. And they are responsible for, first thing, nuclear property. Nuclear property. And they are also responsible for second thing, nuclear reaction. So what I mean to say, that in chemical reaction, only electron take part. In chemical reaction, only electron takes part. But in nuclear reaction, only nucleons take part. Electrons will not be considered. Chemical property of any element is due to number of electrons they have. Nuclear property of any element is due to number of nucleons, number of proton and neutron they have. So here, now we are separating the things. Chemical reaction, chemical property, we are not going to talk because it is nuclear technology. And we have to focus on only nuclear part. So nuclear part, we can sum up like, in nuclear reaction, only nucleons like proton and neutron will be acting and taking part. Nuclear property of any element is due to number of neutron and proton. In nuclear reaction, new element will form. And in nuclear reaction, there will be some mass defect. And this mass defect will lead to what? Lots and lots of energy through Einstein formula E is equal to delta mc square. Now forget about how does it happen. That is none of our discussion. We are not going into quantum physics. Right. Got it. Anyway, so now we understand. So next topic that we are going to discuss is types of nuclear reaction. Let's say types of nuclear reactions. Types of nuclear reactions. Right. And the first one is called nuclear fission. And the second one, here I can write, that is called nuclear fusion. This is all 10th class NCERT. I'm just recalling all the points that we have studied so far. It's not a big deal. I know that everybody know about it. आप सब जानते हो. But my duty is to take it in a very common term so that everybody can understand it, right? So everybody of you who are from arts background or commerce background should also get some basic concept of it. So fission is what? Fission is like, where one nucleus split into two nuclei, right? So in fission, what will happen? Symbolically, I'll write. Look at this. One big nucleus, when it is bombarded by neutron, then this big nucleus will split into a smaller nuclei, and then there will be lots of energy. Some neutron will come out, so 3 neutron will come out, and lots of energy will come out. So this is very simple. Big nucleus that has been struck by neutron, that is high energy particle. Now this big nucleus splits into two small nuclei, टूट गया, बदल गया, and then it is happening, right? Whereas nuclear fusion is just reverse. Here, two small nuclei, when it is heated up to 10 to the power 6 degrees C, so at the 10 to the power 6 degrees C, they will convert into plasma state. That means they will lose their atomic structure, and this all will combine to form a big nucleus. Then neutron will come out, and then energy will also come out. And energy over here will be more. Energy over here will be a little less. Too much energy is there here also, but comparison में यहाँ पे ज़्यादा होगा. Right. So that you need to understand first. Look at this very carefully. The diagram says everything. That what exactly happening. Right. And you can see like what is happening there. Can you see? In fission, splitting is occurring. Splitting means what? One big nucleus is breaking down into two small nuclei, and that is called fission. Whereas in fusion, as the name suggests, in fusion, what is happening? Two small nuclei were heated up to 10 to the power 6 degrees C. They convert into plasma. Plasma is fourth state of matter. When you convert something in plasma, that means atomic structure will be all broken. Electron, proton, neutron, they all lose their arrangement. There is no atomic structure. And once the atomic structure is broken, then this state is known as plasma. When atom doesn't exist, only electron, proton, neutron exist in a random manner. And once this plasma combines and condenses, it will form bigger nuclei. I can write one example of it, the real example I can write. Let's say I'm writing over here. So this is uranium 23592, right? It is being bombarded by neutron, so neutron bombardment is there, and then it has converted into barium 56 144, krypton, and 3689, and then 3 neutron and lots of energy has come up, right? So this is what our nuclear fission. You can see like this is big nucleus struck by neutron, then 2 small nuclei came up, new element formation took place, 3 neutron energy came up. Here I've already written hydrogen 3 1, that is tritium, hydrogen 2 1, that is deuterium. You heat it up to 10 to the power 6 degrees C, you convert it into plasma, and then you convert it into helium 4 2, then neutron, and then lots many energy. So this is your nuclear fission and fusion. Basic concept, nothing much, NCERT, 10th class, and you all have studied it. ठीक है? So I'm not going to the definition. That is what you have to understand. Now, this is what the difference between these both, nuclear fission, nuclear fusion. In terms of energy, the nuclear fission is going to give you more energy. In terms of radiation, you know that nuclear technology is there with radiation. So radiation problem is more over here, right? So we can add some points there. Or point kya hai? More radiation, comparatively less energy. Here we can write less radiation, so this is quite safer, and more energy, right? One more thing I can tell you, that atom bomb is based on this, and whenever we call it hydrogen bomb, then it is nuclear fusion, right? So we have both, we have both atom bomb and hydrogen bomb. So now we'll talk about one by one that what are the ways to get the energy out of it, because obviously we want to get this energy. Our concern is to get this energy. Why this energy is considered to be better? Because in both of these energy sources there is no greenhouse gas emission, right? So the best thing that you can talk about, that no greenhouse gas. So here also no greenhouse gas, here also no greenhouse gas. And if there is no greenhouse gas, then it is very important for us because this is clean energy. Although some problem of radiations will be there, but then we can overcome it, we can manage it, and we are managing it, right? Perfect. Very good. So now we'll focus on fusion. And if you want to carry out fission. So now we'll focus on fission. And if you want to carry out fission, then for fission you need to have fission reactor. And in this fission reactor you will have to work upon something, right? So next topic is fission reactor. So fission reactor is a device where you can carry out fission in secure way. So with security you can carry out fission, right? And in the fission reactor, the parts of the fission reactors are what? We'll talk about first the nuclear fuel. That what are the fuel of this reactor? Because obviously fission reactor will give you, what it can do. Fission reactor, it give energy by controlled fission. You can control fission over there and you can get the energy out of it. So what are the part of it? So first is nuclear fuel. Second one is moderator. Third one is control rod. Fourth one is coolant. Fifth one is reactor core. And the sixth one is shield. Shield means the entire protection mechanism, right? So these are the 6 parts of the fission reactor, and we'll talk one by one each of them, right? One by one each of them. You want that? So let's talk about the first thing, that is called nuclear fuel. So one by one, fission reactor is a device, a setup which can provide you energy by controlling the fission reaction in it. And now this fission reactor will have all these parts, the major part. And the first part of this is nuclear fuel. Or you can call it fission fuel or fission fuel. Nuclear fuel or fission fuel. Got it? So first of all, we need to understand there are 3 types of it. A is called uranium, then B is called plutonium, C is called thorium. Uranium, plutonium and thorium. These 3 things are there, right? Out of this, uranium is considered to be most popular one because all 22 reactors of India which is active at this particular time are running on uranium. So we'll take one by one. The first topic that we are taking out there, the first topic is uranium. And I can tell you one thing about uranium, that uranium is most popular nuclear fuel. Why? Why most popular? All 22 fission reactors of India is uranium based. So that is how it is most popular, you can say, like, right? Most popular. One more thing is there, that this uranium is mined out. So uranium has got ore. You know ore? So basically uranium is a metal, and when you mine out any metal, you mine it out as ore, right? And ore of this is called pitch blende. Pitch blende. Pitch blende. So pitch blende is a ore, and we'll have to purify the pitch blende, and then you will get uranium, and then you get different type of uranium. So once you purify the pitch blende, you will get different type of uranium. And what are those different type? You get uranium 234-92, that is the one type of uranium. Then you get uranium 235-92, that is another type of uranium. And then you get uranium 238-92. Right. Got that? And this will be coming in a different proportion. So this is very less, negligible, trace amount you can select. This will be only 0.7%, and this will be 99.3%. So the whole story is that once you excavate, you want to get uranium, so you will have to excavate, you will have to mine out pitch blende, because that's the ore of uranium. And if you purify pitch blende, then you will get three types of uranium out of it: 234, 235, and 238. These are the atomic mass of the uranium, and these all are isotopes. These are called isotopes. So these are isotopes of uranium. So how many isotopes you get? 3 isotopes. What is isotopes? Isotopes are nothing but a different atomic mass and same atomic number. So you can see like atomic number is same, but the mass number is different. So 3 of them. Now out of these 3, which one is nuclear fuel? So your nuclear fuel is this. This is your nuclear fuel. So this is our nuclear fuel. So this is our nuclear fuel. You get that? It's not like 99.3 can use it. No, you cannot use it. As a nuclear fuel, the nature has given us uranium-235. But the problem with uranium-235, it is too less. It's just 0.7% of the entire lot. And this concentration will not be sufficient. This concentration will not be sufficient. So we have to increase the amount of it. We'll have to improve the concentration of it. And for that, what we do? We do enrichment. What we do it? Enrichment. So next you can do what? Let's talk about. So originally, uranium-235-92 is just what? 0.7%. And that is too less. That is too less. ये बहुत कम है. It cannot be used directly into the nuclear reactor because concentration of proportion is too less. So we'll have to put it under enrichment. Enrichment to increase the percentage of uranium-235. So enrichment is a process, and that is done to increase the percentage of uranium-235. And after this enrichment process, you will get 3 types of uranium. 3 types of uranium, right? So you're going to get 3 types of uranium out of this. One is called slightly enriched uranium. I'll write it properly. Slightly enriched uranium. That is called SEU. Then we have low enriched uranium. That is called LEU. And then we have high enriched uranium. It means that uranium concentration has been increased up to 3 level. In HEU, the concentration is 20% to 90% of what? Uranium-235. Here it is 2 to 5%. And here you can see like it is 1.1%. Originally it was what? 0.7%. But by the process of enrichment, we have increased the amount of this uranium up to these 3 percentages. 1.1 slightly enriched uranium, 2 to 5% low enriched uranium, and then we have high enriched uranium, that is 20 to 90%. Now this both is for nuclear reactor. Nuclear reactor. This is for nuclear reactor, and this can be used for atom bomb. So if you want to make atom bomb, then which level of enrichment you need to do? You need to do enrichment up to 20 to 90%. 20 to 90% enrichment will be required. But if you want to run your nuclear reactors, then no problem. Then you can go with the either slightly enriched uranium or low enriched uranium. India want to this. This is for India. So Indian reactors are here. We need low enriched uranium. Got it? So for us, the most important for the peaceful energy is low enriched, and for us, for weapon system, we need HEU, and we are able to do it both. हम लोग दोनों कर लेते हैं. कोई issue नहीं है. Right? So this is about uranium. This is how the uranium can be used. But the second one is plutonium. So let's talk about that also. The next one that we have already talked about, plutonium. Plutonium is man-made element. So it is not something that we have developed. No, it is man-made element. It is not something that we can mine. It is man-made element, right? And it is considered as most efficient nuclear or most efficient fission fuel. So in terms of fusion, it is most efficient. That means most energy, maximum energy will come out of the plutonium. And at the same time, it is very important for weapon system, right? So this is preferred for weapon system, like preferred for weapon system like atom bomb. So you want to make atom bomb, then most preferred should be plutonium because energy is more, right? Now, if it is man-made, then how do we make it? बनाते कैसे? Plutonium is nowhere in this world. You cannot mine it out. There is no way that you can mine it out. कोई तरीका नहीं है mine करने का. So how do you make it? So plutonium can be made by this process. Uranium-238, you remember? So uranium-238, that was 99.3%. That can be converted into plutonium if we bombard some neutron on it. Then it will trigger a nuclear reaction, and after a nuclear reaction, this will convert into plutonium 239 94. So that is plutonium, and this process is known as transmutation. What we call it? Transmutation. So by the process of transmutation, you get it. So if you want to get plutonium for your nuclear reactor, then first of all you need to have uranium-238. Bombard this uranium-238 with a neutron, and once you have bombarded it with a neutron, then you can get plutonium out of it. And this process will be known as transmutation. So there is no ore, there is no mining, nothing. All you can get is this, right? And remember one thing: special reactors are needed. So you can write for plutonium-239, special reactors are needed. That is called FBR. That is for fast breeder reactor. So fast breeder reactor will be needed for that, right? So for plutonium to be used for energy production, fast breeder reactor will be needed. It's a special type of reactor, and we'll talk about this reactor in the coming time. So first of all, you need to understand this plutonium and thorium. These are the two things that we need to understand, right? You got that, right? So I'm sure that you don't have any doubt. And if there is any doubt, then I will tell, because now I'm missing you all terribly. I want to see your names on my screen. I want to interact to you. So now I'm going to request, rather I will going to pressurize the PW team to connect me to you in a live manner, not this recorded manner, because after this 3 class, in this 3rd class, I'm not enjoying it anymore, right? So I'm kind of missing you all, right? But again, I just wanted to continue with these classes, and slots was not available, and you also having lots many classes with you. That is why, and I'm also having offline class, so this slot is free only. But as they promised that within few days only, the slots will be free and they will accommodate me, and they will connect me live with you. So that is going to happen very soon, right? Anyway, so as this offline classes goes very fast if it is recorded, so I think I should stop here because this is too much to handle, and this is nothing but a recall, and you all need to go through it, and you can put all your queries. Next class when we meet live, then I can take all the queries, so we can have a 15-minute session on queries only, and we'll talk about it, right? So that is all for today, and I'll meet you soon, maybe in the live class directly, and then we can have more conversation and more topics will be added into it. We are having 2 topic mode. One is this, and another one is defense technology, right? So take care, bye bye, thank you.